Defining an Intelligence System in Deep Learning. Pradeep K. Suri. Author and researcher. Defining an intelligence system in deep learning involves understanding the key components and processes that make it function effectively. A deep learning intelligence system typically involves the use of artificial neural networks, which are designed to mimic the human brain's structure and learning capabilities. Here's a step-by-step explanation of how to define an intelligence system in deep learning. 1. Artificial neural networks, and at the core of deep learning is the concept of artificial neural networks. These networks consist of layers of interconnected nodes, known as neurons. Each neuron takes input, processes it, and produces an output that is passed on to the next layer. The depth of the network refers to the number of hidden layers it contains, giving rise to the term deep learning. 2. Training data * Deep learning intelligence systems require large amounts of labeled training data to learn patterns and relationships in the data. This data is used to adjust the parameters of the neural network during the training phase. 3. Loss function * A loss function is used to measure the difference between the predicted output and the actual target. The goal of training is to minimize this loss function, which effectively means reducing the errors made by the model on the training data. 4. Optimization algorithm * To minimize the loss function, an optimization algorithm, example stochastic gradient descent, ADAM, is used. It iteratively updates the parameters of the neural network in the direction that reduces the loss. 5. Activation functions * Activation functions introduce nonlinearity to the neural network, allowing it to learn complex patterns in the data. Common activation functions include ReLU, rectified linear unit, sigmoid, and tan. 6. Forward and backward propagation * During the training process, the neural network performs forward propagation to make predictions based on the input data. It then computes the loss and performs backward propagation to update the model's parameters based on the computed gradients, making it better at making predictions. 7. Generalization * An intelligent system should not only perform well on the training data but also be able to generalize to unseen data. Generalization ensures that the model can make accurate predictions on new, previously unseen examples. 8. Hyperparameter tuning * Deep learning models have various hyperparameters, example learning rate, number of hidden layers, number of neurons, that need to be carefully tuned to achieve optimal performance. This process often involves experimentation and validation on a separate validation dataset. 9. Inference * Once the model is trained and optimized, it can be used for inference. During inference, the model takes new, unseen data as input and produces predictions based on the learned patterns from the training phase. 10. Continual learning, optional in some cases, an intelligence system may be designed for continual learning, allowing it to adapt and update its knowledge with new data over time. In summary, an intelligence system in deep learning relies on artificial neural networks, vast amounts of labeled training data, optimization algorithms, and hyperparameter tuning to learn from data, make predictions, and perform tasks in an intelligent manner. Its performance depends on the quality and quantity of data used for training, the architecture of the neural network, and the effectiveness of the optimization process. Thank you.